Jeremiah 17, verse 5. Thus says the Lord, Yahweh B'Shem Yahushua, cursed be the man that trusts in man. Cursed be the man that trusts in man. Ecclesiasticus chapter 12, verse 10. Never trust your enemy. Never trust your enemy.
To the devices that control them. To make the legs, a 7 nanometer thick sheet of platinum is coated on one side with an legs, a 7 nanometer. That means the tiny legs can be added directly to the devices that control them. To make the legs, a 7 nanometer thick sheet of platinum is coated on one side with an inactive material like graphene. The legs are then patterned using a technique called lithography, and the excess material is removed. In order to work, the legs need to be in water, but the concept is relatively simple. When a current is passed through the platinum, charged water particles are attracted to the uncoated surface. The force of these particles binding to the metal creates stress on one side of the sheet, and that is what makes it bend. By reinforcing sections of the sheet, the bending can be controlled more specifically, and voila, a tiny robot leg. The robots are equipped with 2 minuscule solar cells. By shining a laser on each one, researchers can create the voltage which activates the front or back legs. These new actuators allow the tiny circuit to move, and because they are created using the same well-understood manufacturing processes as semiconductor electronics, their production can be easily scaled, making millions of tiny robots at the same time. Swarms of robots so small that they can be injected through a hypodermic syringe and collected using a pipette. Now, at the moment, they can't do much, but their compatibility with existing microelectronics makes them versatile. In theory, new actuators based on at the same time. Swarms of robots so small that they can be injected through a hypodermic syringe and collected using a pipette. Now, at the moment, they can't do much. Swarms of robots so small that they can be injected through a hypodermic syringe and collected using a pipette. Now, at the moment, they can't do much, but their compatibility with existing microelectronics makes them versatile. In theory, new actuators based on these designs could be combined with more complex devices to carry out a whole range of more sophisticated tasks. The researchers have pointed to everything from fighting cancer to tackling crop pests. But that is decades away. Time will tell if these first small steps for micro-robots could be a giant leap for micro-robotics.
The surgeon, as he put it. So what is nano? Nanotechnology is the science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Let's put that into a perspective. The ratio of the Earth to a marble is roughly the same ratio as a meter to a nanometer. A nanometer is 1,000,000 times smaller than the length of an ant. A strand of DNA is 2.5 nanometers in diameter, making them the perfect candidate for a basis for nanorobots. There's a couple of types of nanobots in existence today, but right now we'll focus on those made from DNA and those that are man-made. So let's take a look at the state of the art. Researchers at the University of San Diego developed nanorobots capable of cleaning toxins from blood generated by harmful bacteria. These nanorobots are about 25 times smaller than the width of a human hair and are made from a combination of natural red blood cell and platelet membranes and artificial gold wire. They can be controlled by ultrasound, which eliminates the need for a battery during propulsion. While still experimental, early tests have proved successful, with nanobot-treated blood containing 3 times less toxins and bacteria than untreated blood. The scientists note that, quote, "This is a proof-of-concept platform for diverse therapeutic and biodetoxification applications," end quote.
By using this natural biomaterial membrane coating our microrobot, we can impart new functionality, new capability like removal of pathogen and toxin from the body.
Researchers at the Arizona State University and the National Center for Nanoscience and Technology of the Chinese Academy of Scientists injected nanobots made from a folded sheet of DNA into the bloodstream of mice. To perform their study, first, scientists induced aggressive tumor growth in the mice. Once the tumor was growing, the nanobots were deployed to come to the rescue. Each nanobot is made from a flat, rectangular DNA sheet 90 nanometers by 60 nanometers in size. A key blood-clotting enzyme called thrombin is attached to the surface. Thrombin can block tumor blood flow by clotting the blood vessels that feed tumor growth, essentially leading to the tumor's death. First, an average of 4 thrombin molecules were attached to the flat DNA scaffold. Next, the flat sheet was folded in on itself like a sheet of paper into a circle to make a hollow tube. These were then injected via IV into a mouse. The nanobots then traveled through the bloodstream, homing in on the tumors. The key to programming a nanobot that only attacks a cancer cell was to include a special homing device that specifically targets a protein that is made in large amounts on the surface of tumor cells. The thing is, this protein is not found on the surface of healthy cells. The result is a DNA device that seeks out tumor blood vessels and is programmed to release its blood-clotting cargo right into the heart of the tumor, killing it. The nanobots worked quickly, congregating in large amounts to surround the tumor just hours after injection. According to the scientists, this technology is a strategy that can be used for many types of cancer, since all solid tumor-feeding blood vessels are essentially the same. So here were the results. 3 out of the 8 mice receiving the nanobot therapy showed complete regression of the tumors. The median survival time more than doubled, extending from 20.5 days to 45 days. Healthy tissue was left untouched, and I think this is pretty good for such an early trial. They also tried their system with lung cancer. The tumor tissue showed shrinkage after 2 weeks of treatment. Professor Hao Yan, one of the lead researchers, weighs in with his thoughts. I think we're much closer to real, practical medical applications of this technology. Combinations of different rationally designed nanorobots carrying various agents may help to accomplish the ultimate goal of cancer research, the eradication of solid tumors, end quote. Yan and his collaborators are now actively pursuing clinical partners to further develop this technology. A nanobot device is roughly the size of a red blood cell or smaller. This is too small to add elements like a motor, computer chip, or camera, so bioengineered bots made from DNA are a common platform for such medical tasks. But as you'll see next, nanobots made from man-made materials are possible and are currently being used in research right now. So here we come to our featured story, which was the inspiration for this video. Not long ago, I was contacted from someone from the Max Planck Institute in Stuttgart.
Barakatah Yahweh, Barakatah Yahweh Shah. All praises to Yahweh Ba'ashem, Yahweh Shah, Ba'ashem Rikakadash. Double honors to the elders pushing the truth. Peace of the elect worldwide. Our kingdom is at hand. Shalom.